In this demo, we're going to showcase the compute to the data capabilities of Nevermind. Um, in Nevermind, data providers have the ability of not only making their data available for downloading, but if they don't feel comfortable with that, they can also uh, have their data remain private but only allow computations over the data. So Nevermind provides a generic framework for that. And in this particular example, we will be running a federated learning session. So for those who are not familiar with federated learning is a form of distributed machine learning that enables a model to be trained over some data and having that data remain private in whatever premise the data is. So a typical federated learning session starts with a bunch of participants connecting to a coordinator, and in the beginning of a round, the coordinator will send to each participant the current model. Each participant will train over their own data, and since the data is different, each participant will create a slightly different model, and all those models are then sent back to the coordinator and they are aggregated into a new global model, and this keeps going until we finish the numbers of rounds that we specified in the beginning. So in this particular use case, we will have a data consumer that it will discover two different data sets provided by two different data providers, and these data sets contain some data about residential homes in a particular area. And the goal is to train a model that can, based on that data, is able to predict final prices of houses, giving some features of the houses. So the setup that we're going to be using is we're going to be using the entire Nevermind stack. So we will have the blockchain that will take care of all the access control to the data and all of the payments. We will have two data providers, each one providing a different data set, and we will also have an infrastructure provider. It's similar to a data provider, except that it only provides computation and not data. And then we will have a data scientist that will basically pay for access to the data of both data providers and pay for the infrastructure provider for running the computations, and it will then fetch the results of the federated learning session. So for this demo, we're going to be using the Nevermind command line interface. And we're gonna start by creating a new account, and we're gonna make it our main account, and we're gonna set a password for the account, let's call it secret, and a location where to store the account information. Afterwards, we need to request some Ether. This will be used to pay for transaction fees. And we will also need to request some Nevermind tokens so we can actually pay for the access to the data and for the compute to the data. So now that we have an account created and we have funds in the account, we can go ahead and actually run the demo. So we will start by being in the role of the data providers. So we have two data providers that first need to publish metadata about their data sets. So let's do that. So the first data provider wants to publish a data set called data part 0, and it doesn't really want to allow data consumers to download the data, so it will specify the services being only compute to the data. And then it's gonna specify also a URL to where the data is located. Once this is actually published in the Nevermind network, this URL will be encrypted and it will only be accessible to whoever pays for access to the data. In this case, since it's compute to the data, the only person capable of accessing this URL will actually be the data provider. Okay, so we will go ahead and do the same for the second data provider. So this is a different data set. And finally, we will have the infrastructure provider. So what it does is basically the same as a data provider, except it doesn't actually provide any data. It only provides computation resources. Okay, so now we're going to be performing the role of a data consumer. So through a marketplace, the data consumer found these data sets and this third infrastructure provider, and now he writes a machine learning algorithm, and now he wants to actually run the computations over these two data sets. So the first thing that the data provider will have to do is to actually publish the algorithm. So it has some metadata about the algorithm, what is the language in which it's written, in this case Python. It has a container, so in this case the data consumer actually provides a container with or a Docker image with the algorithm, and the entry point is just the instructions on how this should be run once the execution environment is set up. So in this case, it's going to run a participant pointing to some data directory, a URL for the coordinator, and it also writes some performance metrics to the Nevermind outputs path. The Nevermind outputs path is an environment variable that is provided in the execution environment, and this is where any files that should be returned to the data consumer should be saved. Okay, so let's go ahead and publish the algorithm. Okay, so now that the algorithm is published and the data sets are published, a data provider that wants to run compute to the data needs to define a workflow. And a workflow basically defines what kind of input data we want to use and what kind of algorithm we want to run. So let's go ahead and do that. So we need to specify the inputs. So we will need to do this for every data set. So we will want to use for the first data set, we use the compute to the data ID, and we also need to specify the algorithm, which we call transformation, and it's this one, the algorithm. So now we have a workflow saying that we should run this algorithm over this data. So now we're going to do the same for the second data set, which was this one. And the transformation will be the same as our algorithm. Now we still need to publish a third workflow, which is for the infrastructure provider. Uh, there is another way of using the command line interface without having to specify all the metadata here. We can have the metadata already in some predefined JSON files. So, for instance, for the coordinator, we have this JSON file that has some metadata, and it specifies what type of computation we want to do. In this case, we want to run a federated learning coordinator, and we can use this information to actually create the workflow instead of specifying everything in the command line. So we can just import this file, and this creates a workflow the same way as the previous commands. Okay, so now that we have 3 workflows published, the only thing that's missing is actually paying for access to the data and for the computation. So let's do that now. We need to make 3 orders, one for each provider. So the first one would be this one. So let's order this dataset, and we're also going to specify what service we want to use. In this case, the compute to the data, which has a service index of 4. Okay, so we have a service agreement ID, meaning that the funds were already transferred to that provider, and we're going to do the same for the other 2 providers, which is this data set. And again, this has a service index of 4. So we have a service agreement for the second provider, and we're gonna do it again for the third provider, which was the coordinator, the infrastructure provider. And again, this has a service index of 4. Okay, so now we have everything set up. The only thing remaining is to actually execute the computations. So we have to execute the 3 workflows. So in this case, I'm gonna start by executing the coordinator. The coordinator was this one, and we also need to specify what was the service agreement. Service agreement for the coordinator was this last one. And we also need to specify what actual workflow we want to execute. So it was this last workflow. We we forgot. It should be assets execute. Okay, so we started the execution of the coordinator on the infrastructure provider. We can check the infrastructure provider, and here we can see that a new compute job has started, and the coordinator is running, and now we want to actually run the other two workflows for each participant. So we want to run the first data set, which was this one, and we want to specify the service agreement ID for this data set, which was this first one. And we want to specify the workflow that describes how this execution should be carried. Okay, so now we have a second job running in the second infrastructure provider, and we'll do the same for the last workflow. So this was for the second data set. Service agreement ID, which was here the second one, and the workflow. And this should be the second workflow. Okay, so now we have the coordinator and the two participants running, and we can also check through the command line interface the status of the computation. Some computations may take longer than others, so let's check the status of the coordinator. Give the service agreement ID for the coordinator, which was this one, I think. And we also need to pass in, shouldn't be enough, yeah, and we also need to pass in the execution ID. And we can also say we want to follow the status of the job. So this command will keep running until the job actually finishes, which it already did, which means that it also would also give us the ID of the output files, the result of the computations, and we can also check here on the dashboard that everything finished. So we can just go ahead and actually download the results. Pass it the ID. So let's take a look at what was downloaded. So as we can see, we have 10 models, which is the results of, or the state of the model after each round, and we did 10 rounds, and these are just serialized models, serialized NumPy arrays. And we can also check, for instance, the computation of a participant. So let's say this last one. So need to pass the service agreement ID. And also the execution ID. So the last one was this. Yeah. So we know that it succeeded, so we can also download this output. And we can check what we just downloaded. So this was the performance metrics printed by one of the participants after each round, and we have the information about the loss and the accuracy of the model. So we see the loss going down and the accuracy going up, and that's it. We just interacted with the 3 different providers and ran a federated and trained a model over 2 different data sets.